It's now my pleasure to introduce Dr Mariagrazia Squicciarini to give the conference keynote address and to outline the work she has been doing on the Digital Skills Project. Dr Squicciarini is the Senior Economist, Head of Unit at the OECD Directorate of Science, Technology and Innovation. In this role, Dr Squicciarini is responsible for the OECD Working Party on Industry Analysis, which develops indicators and quantitative analysis related to changing determinants of growth and productivity. And the key areas of this analysis include knowledge-based capital, intellectual property rights, global value chains, and of course jobs and skills in the digital transformation. Dr Squicciarini leads the intellectual property rights work of the Directorate and oversees the Directorate's Microdata Lab initiative. And this initiative enables the study of firm-level data to provide valuable insights into what is driving the headline economic statistics, such as productivity and growth, thereby supporting evidence-based policy. Dr Squicciarini chairs the OECD Intellectual Property Task Force and is the organiser of the annual Intellectual Property Statistics for Decision Makers Conference. She holds a PhD in economics from the University of Essex, and has had previous appointments at the VTT Technical Research Centre in Finland, the University of Essex, the European Commission Joint Research Centre called the Institute of Prospective Technological Studies, and the Italian National Research Centre for the Development of Advanced Materials. She has published numerous scientific papers and reports and acts as a reviewer for many international peer review journals. Ladies and gentlemen, we are privileged to have Dr Mariagrazia Squicciarini here today with us as our keynote speaker. So can you please give her a very, very warm Aussie welcome.
Thank you. Good morning, everybody. And thank you very much for having me here. It's really an interesting conference, and the topic is absolutely interesting and relevant, we find. So by the time, I don't know whether my slides are on. So bear in mind that this will be the first experience for me of giving a speech at about 4 a.m. in the morning. I just arrived yesterday, just so that you know, if at a certain point I lose my... Can you please put the slides on? So just that, yeah, they vanished.
Sorry, this one here.
Yeah, but it didn't go. Okay.
So that.
Right. Yeah, that's what I pushed before. So what I'm going to talk to you about is jobs, works, and skills in the digital transformation. Now, you heard several things about this issue already. And actually, to answer the question that was posed before, I'm not going to give a definition of what Industry 4.0 is. But surely we are trying to get an operational definition that is trying to measure this phenomenon, which is really a tale of many tales. So let's put a bit of the context first, and then we will go deep into the analysis that we have been doing over the last year and a half. This project, this first leg of the so-called Going Digital horizontal project, which is about making the transformation work for growth and well-being, started last year, is going to finish this year, and then will continue with more analysis, especially focusing on artificial intelligence. So what was the issue? Well, the issue was to try and help policymakers to better understand the digital transformation that is, and to develop tools that could help create policy environment that is enabling both economies and societies. I couldn't agree more by the point made before that it's not about only the economy, it's about society, it's about well-being. And how, to cope and thrive in societies and economies that are progressively more digitally embedded and data-driven. Also, we would like to move beyond what could be the approach related to one single part of the policy house, one single ministry, for instance. We need to go for a whole-of-the-house perspective of what are the state defects and what are also the expected benefits and the challenges that are raised by the digitalization. And this is true for many different sectors and many policy areas. Last but not least, how do we get there? Well, by providing evidence-based policymaking. Hence, our emphasis on especially some building blocks And in the course of these 2 years, we have been focusing on the jobs and skills, and this is what I'm going to talk more in detail about productivity, competition, and market structure, and also about the societal challenges and well-being. And everything here is informed by what we call a kind of this is OECD jargon, it's a horizontal project which is about the measurement of the digital transformation. And that's actually what I'm going to start and talk to you about. So first of all, with respect to jobs and skills, what are the objectives of the work we are carrying out? Well, to understand how the digital transformation is changing labor markets, jobs themselves, the tasks that are performed on the jobs, and hence the skills that workers need to thrive in the market. And the objective ultimately is to inform policy and help policy address the challenges of the digital transformation. As I mentioned before, we think of the digital transformation as a tale of many tales. And this is because sectors differ along many dimensions. To start with, they differ in the extent to which both develop and adopt new technologies. We have just been discussing a number of technological challenges that lie ahead. We know, and the previous speaker emphasized the fact that they didn't like to talk about blue or white collars. Well, let's talk about pyjama workers. Really, we cannot anymore talk about certain stratified type of workers. We need to think broader. There are jobs that can be done in remote places at a distance, and of course entails a completely different set of commitments, and also of questions, for instance, related to job quality, insurance of these workers. And last but not least, and this is a point that was already made, the structure of sector is different. Think just simply about how much sectors differ with respect to their composition in terms of small, medium-sized firms and big firms. And of course, the likelihood of automating, for instance, is not the same whether you have a structure of an industry which is made preponderantly of big firms as compared to sectors of the industries where you have mainly small firms, where really it's very difficult to make the sunk investment needed in order to automate. And also think about the fact that all these dynamics happen worldwide at the same time. There is no such a thing as someone being excluded from the world game, and production is very much organized along global value chains, and we need to take that into account. Digitalization, by its very nature, breaks boundaries. It's very difficult to avoid, for instance, that you post whatever video on YouTube and someone else from, say, America or Europe watches it. So it's really international by its very origin. Oops. Okay. So, of course, then, given the multidimensionality of the phenomenon, it gets very challenging to measure it. But nevertheless, we are trying, to face the hurdle because we need to help policymakers also then shaping the policy on the basis of the evidence, so we need to measure it. So what did we do? Well, we try to account for some of the digital transformation main facets. Especially, we try to get indicators about the technological, the market, and the human capital related feature of the transformation. The other effort we always try and make at the OECD is cross-country comparative analysis, because it's by comparing how you do compared to your peers that you learn how to improve. So this goes beyond, let's say, the examples that were given before between Australia and Germany, but really reaches more broadly throughout the world. But then the challenges become finding comparable data. And also another thing that is very important for the digital transformation is having a sense of where we are going. This is by no means a static phenomenon. It's something that is evolving constantly, and we need to be able to monitor it. So we needed to have data which had a time dimension. We needed to look over time what happened. And then, of course, with that come a bit of challenges related to harmonized classification, deflate, you name it. But these are, details for those that have to do the work. The ultimate aim here is really to give an operational definition. We are not about saying this is the best and this is the worst, but this is to see how different sectors compare with other industries and help policymakers then elaborate policies that will help them perform better and, let's say, cope and thrive in the transformation. And then, of course, with that comes the possibility to benchmark the sectors. This is by no means an effort to try and measure the size of the digital economy. This is not what we are talking here about. But it's about looking at how much penetrated by the digital transformation and its different components industries are. This is important because it has first-order consequences of the jobs that will be available and the skills that people will need in order to perform them. And we're not talking about the future, we are talking about very much today. And responses have to be, there already in place because the change is happening already. So as I said, this is really a tale of many tales. There are so many components. Now I'm highlighting here all the components that we try and put onto the picture, bearing in mind that, as a matter of fact, those that are in yellow are the areas where we still have issues trying to measure them. So we do have a very good understanding of software investment by the time we are trying to look at the technological aspect. So we have a very good idea, thanks to the data we are able to collect and compare across countries and over time, about software investment, about ICT tangible investment, about intermediate ICT goods. I mean, think about tractors nowadays going in the fields full of microchips that then send the information over to the producer or to systems that help, being more productive when doing the work. ICT intermediate services. Think about the fact, many governments over the past years have been concerned about decreasing investment in ICT capital. Well, it turns out there is a lot of substitution going on there, which means that before you used to buy very performing computers, for instance, and those were expensive. Nowadays, companies pay to get on the cloud, so there are services that are purchased. Ultimately, the function is the same, is computing power, but you don't find them anymore in the same very places in the accounts of the companies, and hence you have the perception that they're investing less. Now, if you couple this with how much of, say, for instance, computer performance you get with the same money as compared to what you used to get 10 years before, of course you can easily understand that looking only at hardware investment wouldn't make any sense anymore. You need to look at possible substitutes, in this case is services, for instance. Now, what we did here to try and shed light on the extent to which different sectors have gone digital so far, because this is about data that we have from the 2000 until the 2015. So on the left-hand side of your screen, you will see all the measures that we have used in order to try and capture the technological part of the digital transformation. So software investment, ICT tangible investment, intermediate ICT goods, intermediate ICT services, last but not least, robots, which are the ones that scary, let's say, the public domain discussion because of the redundancies in jobs that automation may create. And then for the moment, but we are already revising this, we only have one measure for the market size, which is online sales revenues. And when it comes to human capital related to the digital transformation, here we focus on ICT specialists. As I said, we are to some extent constrained by data availability and comparability across countries and over time. Now, why do we think this is interesting? Because already looking at these dots, each and every one of them represents a group of industries. So here, industries are grouped in 38 groups, which is a standard way to do so that they can be seen properly. So you can see how much already industries in the very manufacturing sector differ in the adoption of the different parts of the digital transformation. Then one can see how services sectors differ still in their adoption, so how spread, so how far from each other the different sectors are, or otherwise how compact they are in the use of the different features of the technology, and in terms of sales revenues and ICT specialists. And last but not least, we might want to look at those industries that are typically identified to the digital transformation itself, that is computers and electronics and ICT services. So while you see that they are not by brute force in the top part of the distribution, so think about ICT tangible investment when it comes to computer and electronics, but then look at where IT services are. So it's really a tale of many tales. And not the same sector can be very much advanced in the digital transformation along a number of dimensions, and might not be so on other dimensions. also bear in mind that there is what we call a saturation effect. That is, there is only so much you can automate. There is only so much you can purchase ICT. So it's not that by the time some sectors are investing much more or seem to be advancing a lot over a certain period of time, that they are by brute force doing better than others, because perhaps they are starting from already more advanced point. So this is also very important to bear in mind for the policy consequences that it has. As I was saying, and the speakers before me already mentioned it, this transformation is somehow different from what we have observed in the past because of its speed, scale, and the scope. It's pervading each and every part of the economy. There is nothing that is left out. And you'll also see here the differences in which in the progression of the transformation. So I'll just quickly drive you through how different the indicators and the adoption of this indicator looks over time in the 15 years I mentioned, depending on whether we are talking about agriculture, mining, and manufacturing, or conversely, about services industries. So you see that by no means they look the same, and the path that they have followed over the years are also different. So again, the transformation is a tale of many tales. Now, what is, as I mentioned, the thing that seems to be scary the most for governments? Well, the possibility that a big part of the workforce might be made redundant by this transformation. Industry 4.0 seems to, trigger fears of mass unemployment. But what is that we really know about this? What do we know about automation? Well, we did some work about routine workers. These are typically the ones that are feared for the most, are those people that do jobs that are repetitive, that can be easily codified, and because of that, they are either subject to being automated or also offshored. Remember that always a digital transformation happens in a constant of global value chains. So if something is easily codifiable and repetitive, I can do it where it costs less, or I can just automate. We proposed our own definition of routine workers, which is based on data from the survey of other skills and takes into account two main features. That is, the extent to which people, they can change what they do on their job, and the extent to which that they can decide what to do. So not only what they do, but the way in which they do it. So if people cannot really have a big say about that, they are considered more routine workers. Those that typically perform, let's say, also high skills type of tasks, and they have a lot of freedom in deciding what to do and how to do it, they're typically no routine workers. Now, analysis shows that the proportion of high routine workers as compared to the proportion of non-routine and low-routine workers changes a lot across countries. You don't have Australia here just because the data we had were not sufficiently disaggregated to be able to make this exercise, although Australia did participate in the survey of other skills. And so here you can see how the picture differs in terms of the four parts of the distribution, as they're called the quartiles of this distribution, and how the workers in different countries seem to be distributed. Now, if we believe the story whereby automation and routine are correlated, this is, the one in red is the proportion of workers we should be fearing for because their jobs can be automated. If instead we believe the story that is very much taking weight out there, that there is job polarization ongoing, that is what we have observed over the last years, although this is not all due to automation, but there are a number of other, causes around it, is that basically it's the middle part of the distribution of workers, those with middle skills and middle kind of automatable jobs that have been hollowed out from the labor market, whereas jobs, even low-skilled, but that require typically, for instance, personal interactions, as well as the jobs that are highly skilled, those where you are very independent, you can really decide what to do, are the ones that are benefiting from the structural changes we have been observing over the last years. So if you buy the story of the job polarization, the part in orange of the population is the one you might be concerned with. However, we have done analysis that looks at how routine jobs and employment levels look by the time we put them in the context of global value chains. And especially, and this links very well to the presentations that were made before, what happens by the time innovation is there? So typically, and this is a call for more action from the point of view of the academics, trade-related studies completely ignore the innovation part of the story. And we thought it was very important to put together innovation dynamics and trade dynamics to try and understand what can happen by the time the two interact, because they do interact. So what we saw is that, well, in fact, for 100 extra innovations, in this case captured by patents filed at the top IP5 offices worldwide, you get an extra 1.1% of non-routine workers, and you get even an extra 0.4% in terms of employment level of routine jobs. And why is that? Because, of course, if you do more value-added type of activities, and you do them especially at home, what you will get is that, of course, you have to, coordinate, manage, etc., these processes, so there is more job for the high-skilled ones. But very likely, think about, for instance, the iPhone case. Where is packed? Where is the lower end happening? Also in the United States. So it is at the beginning and at the end of the cycle that these workers are let's say, enter into the game. And so that's why we also find that there are routine workers that may grow in employment level by the time there is innovation in a global value chain setting. The same doesn't apply by the time we think only in terms of ICT intensity, and we do find evidence that non-routine jobs benefit from it in terms of employment level, but routine workers don't do that. So we nevertheless think, based on work that our colleagues in the Employment, Labor and Social Affairs Department have done, that despite the fact that we do agree that most jobs will change in terms of the tasks they are going to perform over the next years, and that actually we believe that all workers will see the tasks they perform change to some degree. Well, nevertheless, there is a relatively smaller proportion to the one that was initially put forward by some academics that will be a risk of losing completely the job. So actually our colleagues did work that tried to distinguish with those that are at high risk, defining them as those for which more than 70% of the tasks that they currently perform may be automated. And then those that are a significant risk, that is, those that have between 50 and 70% of the tasks that they perform on the job that are likely to be automated. What we get is a mixed picture, whereby, on average, across OECD countries, 14% of the workforce seems to be at high risk. Now, this is nevertheless a remarkable proportion. We are talking about 14% of the workforce. And then there is another 30%, more or less, that is a significant risk. The bottom line of this is that we need to worry because changes are happening on the labor market, and the type of jobs that will be available are different, and jobs are changing. But it's not that the jobs will be wiped out completely. They will change in nature. So we need to help people transit to new jobs, or help the new entrants enter the job. Now, why do we think that these fears might be exaggerated? Well, not because something is automatable. In theory, it will be automated. And the reason is that, as I said, think about industry structure. If the industry is mainly made of small and medium enterprises, it's going to be difficult to see mass adoption of automation type of technologies. And also because that depends a lot on where you are in the value chain. So whether it's worth really automating or not, and the kind of, say, personal or not interactions that are at stake. So what is that is driving, what we observe? What are the new business models? How do they link to the new jobs we expect to see? And consequently also, what are going to be the skills that are needed on the labor market and that we already see today that they are needed? Well, we do know, and this is a fact, that the nature of work is changing. So putting together information about how intensive in ICT jobs are already nowadays, this is already, again, based on the survey of adult skills and other data sets as well. And so we were able to look and to see the correlation between the routine content of your occupation. So on the y-axis, on the vertical, you see the non-routine employment percentage. And on the x-axis, you see how much intensive in ICT these jobs are. Well, the correlation is positive everywhere. The higher the ICT penetration, basically, the higher the proportion of non-routine jobs. And this is true in manufacturing as well as in market services. So we don't see any big distinction there. Whereas typically it is assumed that services are in this part to a higher extent, which is, data don't support actually. What we do know is that there is what is so-called the great divergence. That is like, compared to the past, more and more we see top performers, the ones which we call the frontier firms, the ones that at the productivity level they are at the very top, that are departing very much from what you find in terms of companies that are the laggards, the ones that perform the worst, sort of. And this divergence is getting wider and wider, and actually it is more so the case, for instance, in ICT services as compared to non-ICT services. Also, what you might want to notice is that companies, the very laggards, oh gosh, the batteries are going out. The laggards in ICT services are actually performing better than laggards in non-ICT services. So we need to understand what are the root causes of these differences in productivity and how they will impact the labor market and hence the skills that are needed for the job. What do we know? And I like this paper a lot, especially the title, which is Manufacturing or Services. This is not the question. More and more, we have total services value added share of manufacturing export, which is growing. And this is true for each and every country. And this is true for both foreign services and services that are domestic. So, and here you see where Australia is. So a big share, in this case, is 40% of total services, of the gross manufacture export is made by services. And this also, I think, support the idea which was put forward that we have to, let's say, stop dividing the world in this kind of juxtaposition between services and manufacturing, and also stop, to some extent, having a kind of a stigma attached to manufacturing jobs. Because very often, if you talk to students and you ask them where they would like to see themselves in the future, they're rather saying something like services companies, app-related companies, ICT-related companies, but you seldom find someone saying, I want to be a plant engineer in the production of, the typical things that are produced in manufacturing, because let's face it, there is some kind of stigma attached to manufacturing jobs, supposed to be less interesting or less challenging than the ones in services. Well, there is no boundary really nowadays between services and manufacturing, so they should be attractive to the same extent, and perhaps you might want to work and convey this message to your future workforce and the current one. And also what we do know, and this is another fact, is that many jobs are sustained by foreign final demand. So that's why I reiterated the fact that we cannot think of the digital transformation as something that is happening only here or in few parts of the world. It's happening everywhere. And in the case of Australia, for instance here, because, the range you see is between the top and the bottom in the different grouping considered, so whether EU 28 or OECD countries, G20 but non-OECD, and in this case I'm singling out Australia. So what you can see here, that a big share of your jobs is sustained by foreign final demand. Why do we call it foreign final demand? Is because it's not only the demand that comes from partners you have a direct contact with, but also those that you serve through intermediaries that can be other countries. Because, let's say, all the statistics about international trade were to some extent flowed by the fact that this second link was missed. And so you couldn't really see the extent to which, for instance, a country was dependent upon other countries or integrated with other countries. But now we have this ability to see this thanks to the trading value added database that OECD coupled with WTO put forward a few years ago, and now we are shaping up even better. So another characteristic of the digital transformation is the one of a scale without mass. I'm sure you have heard this expression. And it's the fact that compared to the past, you don't need huge sunk investment to start a company, and you assist to scale-ups that are unprecedented in the past. So these are companies that were established relatively few years ago, And if you see how big they are in terms of turnover, for instance, or how big they are in some cases, but not in all, also in terms of employment, you realize how different the patterns of firm establishment and firm dynamics are nowadays compared to what used to be the case in the past. Another characteristic of the digital transformation, which of course has an impact on what are the jobs that are available and the skills needed for it, is the extent to which companies nowadays rely on intangible capital. At the OECD, we like to call it knowledge-based capital because it's really about what human capital can bring to the discussion: innovation, R&D, organizational capital, and a number of others. But it's really about what is intangible in the production that matters a lot these days. And as I mentioned, is the servification of the production. So services that are pervading each and every part of the economy. Now, where do these leave us? Well, it will be very difficult to say which kind of occupation. I think many governments and many experts have tried to challenge themselves with understanding what are the jobs of the future. The truth of the matter is we cannot know for sure, but there is a lot other that we know that can help us navigate in the future in the best shape possible. For instance, for the past, we do know that after the introduction of the PC in 1980, against all odds, they were expecting a lot of people to vanish because of the computational ability of the computers. Well, new job titles appeared, for instance, in the United States, and actually Berger and Frey count up to 1,500 new job titles. So technology does not need being job destroying, but it's also job producing. And this is something that is seldom told as a truth, and it's important to bear in mind. Also about what are the skills that are needed. Well, sometimes it can get very difficult to predict, even for people that did shape economies in the past. Karl Benz is one of them. We go back to the German parallel here. And he believed that the market for automobiles would be just limited by the fact that there couldn't be enough drivers that could, populate the market. Well, it turned out to be wrong. Another thing that you need to consider in the digital transformation and its pervasiveness is the fact that disruption might come from competitors you don't expect to be competitors for you. An example is the smartphone. So, of course, they disrupt products, and in this case, their own sister or brother products like notebook computers or personal organizer. But also they have disrupted niche industries, like those, for instance, making musical metronomes or also handheld magnifying glasses, because now you can, use apps to do that. So these are industries that didn't expect competition to come from, let's say, in this case, smartphone, for instance. But what do we know about, anyway, the skills and the jobs that already exist and what will be the future? Well, we do know that the industries differ a lot in the skills content of their workforce. So this is simply putting simple statistics, there is no regression here, about how different in terms of skill endowment the workforce in digital intensive industries. So you've seen the indicators we have shown before, and then we use those indicators to rank industries into digital intensive and less digital intensive industries, just to have a juxtaposition, although it's really a continuum of industries. And you see that typically the workforce is much better endowed in terms of both cognitive skills. Here we refer to the literacy, so the ability to read and understand context, numeracy. That seems to be especially important, and problem solving in technology-rich environment. And then in the context of the OECD Skills Outlook 2017, based on the survey of adult skills, we managed to extract 6 key skill sets that seem to be extremely important for participation on the labor market and performance on the job. And these are the ICT skills, management and communication skills, marketing and accountancy skills, STEM quantitative, that is like going beyond normal numeracy skills. And I've seen, since I landed yesterday, that there is a lot of emphasis. Self-organization, the ability to, cope with change at the end of the day. And then readiness to learn, the ability to find solution, the ability to be willing to overcome problems and think, and, learn also how to learn, which is extremely important in the digital era. So what do we see also is that not only digital industries seem to have a better skilled workforce, but they seem to be willing to pay even more for that. So what you see here, the dark blue, by the time it's shaded, it means it's not significant. So this is actually the results of a regression of analysis, not simple statistics. You see that there is a different payoff related to the different skills that workers have already today on the market. This is what we are talking about. And these are the returns in less digital intensive industries. But what we see is that in addition to what less digital intensive industries already pay for these skills, digital intensive industries are willing to pay an extra. And the extra varies depending on the type of skill we are talking about. So this is important to bear in mind because this points to what industry needs and industry is requiring from the people that are looking for a job, actually. Also, and this is really something that I would invite you to consider very carefully, and this is the fact that compared to what was believed in the past, and I still see some emphasis today, is that it's not one single set of skills that matters, it's bundles of skills. So what we find here, for instance, this is just an example about a pairing between communication and management skills in the context of ICT-intensive jobs. So it doesn't suffice for a worker to have good or excellent management and communication skills. For them to thrive on today's labor market, they need to have also very good intense ICT skills. And the better ICT skills they have, the more the rewards that accrue to them through their jobs, so through the pay they receive, through their salaries. So what matters is bundles of skills, is skills together in the very same person. It's not anymore sufficient to have all companies made of organizational settings where you have different experts for the different skills. You need to have bundles of skills in the same worker. And this, of course, challenges a lot what is the current educational system. Because by the time you go through humanity, you get seldom a very strong endowment, say, of ICT skills or numerical skills. And if you go for the numerical related or the STEM related careers, you get very seldom, say, communication skills, for instance, or management endowment. So you need to rethink how to structure the courses, both education and vocational education. So that's why I found extremely interesting the thought that IBSA had been having, and the fact that by the time they set into this challenge of looking at the digital skills across sectors, they unanimously agree, or very at the beginning, that there were broader digital changes occurring in the marketplace, and therefore they needed to go well beyond coding skills. I mean, you got it right exactly from the very beginning, and I applaud the fact that you changed even before starting the run, because it was important to go well beyond only the coding problem, because the coding problem, you understood very early in the process, didn't come alone, and that was very important to get then the results you get. And what I found very interesting from the answers that you gave in the questionnaire was really that the kind of questions that we have been posing in order then to discuss with policymakers are very much aligned with what it seems to be the kind of question that you in the industries are posing, because often institutions like ours or even policymakers are accused, let's say, to be far away from what industry needs and from what the industry does. And I think this is one of the cases in which we are all speaking the same language and we all are identifying the same problems at stake. And actually, it was interesting to see that you see as challenges in the technology bringing to your sector, like the design, the manufacturing, the production skill and innovation, the adaptability and the transformation of skills, and the access to the appropriate skills and the ability to train and to maintain. So you do perceive these dynamics, and this is something that, of course, is very important in shaping future decisions and current decisions. It's also about the interaction between technical and soft skills, which is exactly what I showed you about. Some minutes ago. Is like you need to complement them in the very same worker. And of course, then there is the question that by the time, the pattern of production change, jobs change, people may need to move to another job. This entails retraining, perhaps reducing the staff number, perhaps not, redeployment for sure, and of course, spending. So investing in human capital, at the end of the day, can be an investment if you believe that your human capital is going to bring value to you, but very often, and too often, unfortunately, is considered a cost. And we need to understand better that this investment is not really a cost. Well, it's a cost in the short term for those who incur it, and then the question becomes how to best share it, because then it is going to benefit everybody, the workers, because they will have a job that will satisfy them and will allow them to earn a decent income, for instance, and industry, because industry will find the workers they need, actually. So, in order to go more in detail about the skills problem, we did work that tried to understand how distant the occupations are in terms of the skill required to perform the job. Why is this important? Because whether you're already on the labor market, whether your job is being transformed because of Industry 4.0 or because of the global value chains related dynamics, people will need more and more to move on the job. I mean, what we used to observe in the past, people entering the labor market and having one or at most two jobs in their whole career, doesn't seem to look like what we expect from the future, because the paradigm is going to change a lot. So perhaps they will stay in this very same job, the job will be called the same, but they will be required to do completely different things. Because, as I said, I fully agree, it's not about job titles or occupational titles, it's about the tasks that one need to perform on the job. And those are changing to different degrees, but in all jobs. So we need to understand how to help people transit to their new occupation, whether this is called the same thing or is a different one, whether it's in the same industry or is in a different one. So we know that the affected workers, and this was triggered actually by the discussion on the automation and how to help people that are made redundant, but it's much more general than that. And we took a much more general approach. It is about how to move people, transit to different type of tasks sets, basically. And so the question was how affected workers need to adapt to changing jobs and find new jobs. And then, of course, the question for policy is how to help them, because what you don't want to see is mass unemployment. And then the question becomes how to help matching, how to help the retraining. We also know very well, especially in recent years, that public resources, there is a call for public resources to be more efficiently used. And of course, this links to the fact of helping people adapt to new job and to switch to occupations that are closer to what they're really able to do, to their skill set. And that actually called for our ability to try and measure what is the distance. So if I have to move somewhere, I need to understand how much do I have to move to get there, and what do I need to do that. So identifying what skills are needed to move to a new occupation ultimately also helps shedding light on what is the balance. This was something that was brought already before, but marginally so, into the discussion. What is the right balance between initial education and adult learning on the job? We cannot expect schooling to keep, school to keep people in schools for, 30 years before they start working, thinking that they are then at that point endowed with all the resources and the skills they need, and then they can go on the labor market, because they will change. So they will need to go back to school or whatever other type of training. And hence the question becomes, what is the right balance? What do we have to think about educational system and adult learning together and look at a life-wide, as we call, rather than lifelong, education and training system that allows people to be always finding their place in the new digital era. So we know, because of analysis already done not only by the OECD but by also several academics, that cognitive skills are typically developed through initial education. And what we think about here is really literacy and numeracy. For the moment, we take aside the problem solving in technology-rich environments, because that question in the survey, that part of the analysis, was not done by three important countries. Important for me, I'm Italian, so Italy, France, and Spain. And so we decided to keep the set as big as possible, also because problem solving in technology-rich environment is very highly correlated with the other two cognitive skills, so it wasn't really extremely important to keep it in the analysis. And we also know that task-based skills are those that are typically developed through adult learning and learning on the job. And here I'm referring to the ICT, the management and communication, accountancy and selling, advanced numeracy, and self-organizational skills. Here we left aside readiness to learn because readiness to learn is actually a characteristic, a social-emotional type of skills that pervades all the others, because the more ready you are to learn, the easier that you improve or acquire skills, both cognitive and non-cognitive skills. So we went and tried to quantify what is the distance between occupations in terms of cognitive skills, as well in terms of task-based skills. And also, and this was very important, to try and understand whether there is some key skill that drives the difference. Why? Because then by the time you go and invest in retraining, that's the first one you want to attack, so to speak. Whereas the other that are kind of relatively less important are ones on which you can focus in a second moment. But in order to allow people to move or enter a certain job, you have to endow them with the most important components, basically. So this, I'll very quickly go through this, because actually what we did, and this is kind of a first-time analysis in this sense, is that our measure of distance is not only unidirectional. So we don't only look where there are the problems. We also look at where are the advantages. That is like, suppose I need to move to another occupation. So I need to understand which kind of skills I need, so what are my skill shortages in order to move to the other occupation. And I need to know which kind of skills I have already, so my human capital is endowed with, that I sincerely wouldn't need when I move to the new occupation. What is the excess? Why do I need to look at that? Well, because I want to minimize what is the skill shortage. And it's important because, if I don't move to something that requires a huge training for me, of course, the cost of that training will be lower. But also because we have an issue with coping with change, let's face it. And so also psychologically, for the acceptance of the worker, it's important that the path to be pursued remains feasible and sustainable in the hand. Otherwise, workers will not be willing to engage in that kind of challenge. And why do we want to minimize also the skill excess? Because I don't want to see any human capital going to waste. Because this will not going to be, it's not going to be useful in terms of overall human capital, but it's going to minimize the well-being on everybody, because it's very difficult to create human capital. So the question becomes, why to waste it? And that's why our measure minimizes on both dimensions, both the skill shortage and the skill excess. So let's see, really empirically speaking, you will see big bubbles here, which tell you how far away occupations are in terms of both the cognitive and the non-cognitive skills. So this is really showing how different, how distant the occupations are from, on average, from all other occupations. This is a simplification. We group here jobs in terms of the broader occupational category they belong to, but just to show this. But you can have this analysis very much unpacked also at the worker level. And so you see on the bottom right part of the screen, those occupations where move are entail basically shortages that are driven by general cognitive skills. On the top left end of the panel, actually the shortage is mainly driven by the specific skills. So each and every job actually is characterized by shortages and effects, and we have the numbers. I mean, by the time we will put forward the next Skill Outlook 2019, we will also put forward the names, so you can use them for your analysis and also to see where you could move your workers in case you do need to do that. And so the difference is, as you can tell, at the lower end, on the left-hand side, at the bottom, you have those professions that seemingly have an easier way of moving elsewhere. At the top right, you have those occupations for which moving elsewhere becomes costly. So you need serious retraining, basically. That's the message of that chart. But here, what you see is what is the distance between occupation, but within the same group of occupations. Why do I want to show you that? It's because I'm sure you're familiar with a number of retraining exercises that have been carried out in the past. And typically, the idea of those exercises was to retrain the person to do more or less the same job elsewhere, sort of. Now, it turns out that in the digital transformation, this is not possible anymore. The reason is that if a certain job is likely to be automated, it is likely to be automated in many industries. So moving these people to a job that is similar but in a different industry might not help very much, because that person can be confronted with the necessity to move again in the short term. And this is highly disruptive for the worker, but it's also disruptive for the industry, because it gets very difficult to find the right people for the job. So you will see the size of the bubble differs depending on how much similar the occupation within that broader occupational categories are, or how much dissimilar they are. So you can see how different jobs look in the agricultural and fishery workers or the elementary occupation. And this was in terms of the cognitive skills. Here you see the very same bubbles, but now measures in terms of the distance within the group of occupation in terms of task-based skills. And you see they are different. And what I want to invite you to notice is also the overlaps, which means that perhaps at times, depending on occupation you're thinking about, it might be easier to switch to an occupation which is called differently, but that actually, despite doing different things, needs to rely on the same kind of skills, then moving within the same occupational category, where actually what I do is completely different from what a person that has a similar title and that person does. Think about computer technician as compared to your fridge technician. I don't think you can convert a fridge or, I don't know, whatever electrical appliances into a computer technician the day after, basically. You will need some retraining, because what they deal with is different. Despite the fact that these days, let's say even washing machines are, managed through whatever digital processes, and so typically we see nowadays the technician coming with a small iPad and just sorting the problem out from a display, and then you ask, what they need to do in remote? That remains a question. But anyway, you have to wait for them to come to your house. And when you have little kids like I have, get serious. So, as I said, what we did also was to look at decomposing the distances. What are the skills that are needed the most? Because those are the ones in which you want to start and invest in the first place. So just very quickly, I'll show you how different, in terms of the different occupational categories, the importance of numeracy and literacy looks like, as well as how important it seems to be ready to learn and adapt to changes. And this is true in terms of cognitive skills. This is also true in terms of the task-based skills that I highlighted before. So I'll just show you how different, really, the composition of the differences, the excess and the shortages look like by the time we consider the different components. Hence, the need to tailor the training in a way that hits first the most important component. What are we doing now? I think something that could be very interesting to you. That is, like, we are trying to account for the differences in knowledge areas and in wages, because I'm sure that everybody understands that by the time you have commitments, or even by the time you don't have them, you don't want to move to a job that pays much less than what you earn today, because you have commitments, you have loans, you have expenses to bear. And the importance of knowledge areas comes from the fact that if you are moving to a job that requires a similar education as the one you have, you might feel it less difficult to move there, because you might feel you already have the basis, the roots are there. We are linking this to the risk of automation to see what are the viable transitions that we might suggest to people to do, and characterize them both in terms of shortage and excess. And last but not least, we are estimating the cost of this upskilling. So basically, we are estimating the cost both in terms of the direct cost, what it costs to take these people to school, kind of fees linked to it, based on the information we have about the different countries, and also what is called technically the opportunity cost, which mainly is these people, especially workers, by the time you have to retrain them, either they go to the training, either they participate in the training, vocational or traditional formal schooling, or they work. So those salaries that are paid to these people by the time they are training are actually not used for these people to continue to produce for you, but they are actually for them to learn. So this is a cost that needs to be considered, because then it might want to redistribute in a different way compared to the past. So let's think, for instance, this is an example. So in the center, basically, you get, let's talk about the assemblers, because I know that's something that is bothering the policies. I was seeing yesterday a television broadcast where they were talking about how difficult it gets to get specific type of workers, and actually you will see some of them here. So assemblers, suppose we want to try and move people that, because of automation, are going to lose their jobs. You see 3 circles here. The first circle is what is like minimal training requirement. We are thinking about training that lasts at most 6 months, okay? This is not our guess. These measures are carefully taken from existing analysis based on the PISA study, on the PX study, that is how long it takes to acquire certain skills measured in cognitive distances. So then we are displaying a circle which we call the moderate training needs. Here we are thinking about training needs of about a year. And the other one that is important training needs, it basically means taking people back to school for 3 years, okay, to get a degree of whatever description. And then, of course, there are moves that we would never suggest to do, but people might be willing to take, that wouldn't take much longer periods. And so let's concentrate on those that are small or moderate, because those are the ones that we would suggest country to support, because the others are very costly. So the others entail completely different financial kind of design. So for instance, assemblers, what we see in the small training needs is that there are a number of occupations that don't seem to be immediately associated with assemblers, like mining and mineral processing plant operator. I heard yesterday that there is a big shortage of these workers. And or for instance, or heavy truck and bus driver, those that have specific skills, not those that, of course, can be automated, as we know, the driverless cars. And so the idea is to try and understand what are the viable and the potential and viable occupational transition that workers, for instance, assemblers, can do with relatively minimal training or as little as possible, and also with minimal waste of human capital. So we are constraining these estimates so that basically you don't waste human capital, you don't decrease the well-being of people. So, and then comes the question of the training. The first one, so we have done some studies about who gets the training, and what are the factors that seem to be associated with the ability to train, because we know that coping with change will require, as we showed, giving some training to these people. Well, in the context of gender-related work we did, we saw that, for instance, when we look at male workers as compared to female workers, the likelihood of getting trained is basically the same. Now, mind you, we are talking about much lower number in the case of women, because participation in the labor market for women is much smaller. So despite the probability being the same, we are talking about completely different numbers. However, by the time females do get into training, they seem to get longer spells of training. Also this, and I have to be cautious here, stems from the fact that you have a predominantly female workforce in sectors like education and health, and their training also for, let's say, safety issues is kind of compulsory, so hence the length of the training that seems to be significant and positive. But at least for once, being a woman, there's something positive to see, actually. But then looking at the workers and the risk of being automated, so we looked at what is the probability of routine jobs to retrieve, to get some training, because actually those would be the ones that need it the most. Well, reality doesn't really go along with expectation, and we see that not only routine workers typically have a lower probability to get any training whatsoever, but by the time they get training, the training is shorter than those that the others, let's say the non-routine workers, get. And we do see that still training is mainly used as a rewarding mechanism. So those that are already well-placed or better endowed, those that have higher skills, in this case especially literacy seems to be driving this correlation. We have a higher probability of getting training and longer training, actually. So, this is something that tells us we need to rethink training system. And as I said, and here you can see Australia very clearly, is that seizing opportunities require skills, and those that are more in need of training actually get it less. So here you see a bit of detail about how much low, medium, and high skilled workers receive formal training, that is the one giving you certifications, and on the job, which doesn't lead to any certification in our jargon. And so you see that the proportion of low and medium skilled workers is very low compared to the one of high skilled workers. So what are the implications for policy of all this? Well, it's really the importance of lifelong learning is that it's important to look at both general cognitive skills and task-based skills. There isn't such a thing as focusing on one aspect. Otherwise, we won't get very far. The skill distances among low-skilled occupations or from mid-skilled to high-skilled occupation typically entail more needs in terms of cognitive skills, and hence the training policy for low-skill occupation need complementing not only training on the job, but we need also to consider endowing these people with better cognitive skills, which in turn also links to the need to avoid that people leave school early. And this is because certain type of skills, and actually even some social-emotional skills, are acquired very early in life. So despite the fact that then you look for them by the time people are on the labor market, they are really, and there is more and more evidence nowadays, it's very recent studies, that says that they are created even at the level of the kindergarten. So then it's really a rethought of the whole education system and accompanying people during their working life. So, well, this I told you already, and what are the reskilling that are needed by low skills and high skill. But what I wanted to close this presentation with is the questions that were discussed just a couple of weeks ago, not even that, in Porto by the ministers in the Skills Summit. And actually, we were asking, ministers, what are the policies that governments are implementing to strike the right balance from front-loaded educational systems as they are now to lifelong and life-wide systems. So how to do that? Nobody seems to have the answer. There are good examples over there, but we need to, continue this best practices survey so that we understand who is doing better than others to be able to then replicate with the necessary adjustment to the different countries. So also is equipping people with the skills for the 21st century doesn't only mean digital skills. And this is something that was made very clear and that we also put to the attention of policymakers. In order to be able to answer that question, we need to answer another question that is like, what are the key obstacles? Unless we understand what are the obstacles, it will be very difficult to, eradicate them. And whether there are solutions that some governments have developed to address them. Okay, this is, sorry. And also is digital technologies are not something only that is needed by the time we work. It's also something that can help us learn. So why not to leverage on the potential of digital technology to foster better learning processes? And this is something that is very much on the table of policymakers. And this comes with all what I told you so far, and this synthesizes it very brutally, is like, who pays for it? So how do we put together the financial resources that are needed to change, and how to create the conditions that are more favorable for society? Who should invest? At what time? How to distribute it? And as I said, the question is trying to understand if and what are governments and social partners doing, especially to promote universal access to basic skills and to bring in disadvantaged population and minority groups. I mean, let's be frank. The digital transformation can be empowering, but can also be, let's say, inequality enhancing, unfortunately, unless we deal properly with it. So we need to be careful at this aspect and already deal with it now, because otherwise it can be too late. And also, how to couple the digital transformation and what are the new skills and the new jobs that will be there with improved social protection. I'm sure you're familiar with all the discussion about to what extent Uber-like type of workers need social protection and how to guarantee that, because social protection nowadays is generally linked to conditions that don't exist in the case of this type of workers, the platform workers. And so it's, and I close here, is like the question becomes how to bring onward all relevant stakeholders, because otherwise a discussion is not really possible. Well, thank you, and sorry for being a bit long.
Ladies and gentlemen, we'll break for lunch in a second, but can I
just bring a bit water.
present our keynote speaker a little gift from Australia?
Thank you very much. That's very kind of you. Thanks.
Can you join with me, please?